Okay, so in the last class, what did we see? Just a quick revision. The cardinality of A cross B, number of subsets of the set A raised to B, that will be give us number of relations from A to B. So that general property we saw, if cardinality of A is P, of is Q, then the number of elements in A cross B number of elements will be PQ. And if I tell you number of relations from A to B, so number of relations from A to B, this is actually number of subsets of A cross B. So A cross B cardinality PQ. So total number of subsets, how much? 2 raised to PQ. Okay. Then let's say we did some examples related to the relations, and we saw the definition of domain, codomain, and range of a relation. What is the meaning of domain? Domain means, rough definition can be set of all first elements of the ordered pairs. You collect the first elements in the ordered pair, that is together called as the domain, that set. The range is set of elements of the second element, set of all second elements is called range, and codomain is the second set which is there from A to B. The second set completely is called as codomain. That was the definition. So just property is just domain is a subset of the first set, that is A, range is a subset of the second set, that is B, and B is called as a codomain. So this was relations that we saw till now. So relations as such is over here. Now today we will start with functions. Now what is the meaning of a function? Now function, if I tell you how relation is defined from a non-empty set A to another non-empty set B, correct? So function is also defined from one non-empty set A to another non-empty set B. Function is actually a special kind of a relation. You impose some special conditions on relations to make it a function. What are those special conditions? Or let's say a relation from non-empty set A to non-empty set B is called a function if each and every element of A is related to exactly one element, of B. So let's say consider now set A is equals to, consider 1, 2, 3, 4, and set B is equals to PQRS. Okay. Consider R1. I could define one relation as, let's say, 1 is related to P, 2 is related to Q, 3 is related to R, and 4 is related to S. So can you see that each and every element of A is related to one element? So this is a function. This is a very most trivial case that I have given you. This is a function. Let me give you some more examples. Let's say R2 is equal to 1 comma P, 2 comma Q, 3 comma R. Whether this will be a function. So this is not a function. This is not a function. Why? The reason here is, what is the reason? Because what is the condition? Each and every element of A. Each and every element of A should be related. Now we have an element 4 belonging to A, but 4 4 is not related to any element. 4 is not related under to any element under R2. In the relation R2, 4 is not related to any element. Okay. So this is not a relation. Now let's say consider another example, R3. R3 is equals to 1 comma P. Okay, sir. So now we understood that, sir, 1, 2, 3, 4, all these elements should be related. So, okay, let me say, sir, let's say 1 is related to P, 2 is related to Q, 3 is related to R, 4 is related to S, and let's say 4 is also, or let's say, forget 4, let's say 2 is related to P. So this again is not a function. This again is not a function. And what is the reason? Because the reason here is this problematic element 2. In the definition, what do we have, sir? Each and every element of A should be related. Okay, that condition is satisfied. 1, 2, 3, 4, all the elements are related to some elements. But what is it to exactly, what is the another condition? Each and every element should be related to exactly one element of B. Here the element 2 is related to Q also, and it is related to P also. The element 2 belonging to A, 2 is related to Q, and 2 is related to P. It is related to two elements. Therefore, this R3 is not a relation. Okay, there are two images. I have also told you the word, the vocabulary, image and pre-image. There are two different images of the element 2. Okay, next consider this example. So 1, 2, 3, 4 all should be related. Okay, you told that in from R2, considering the example of R2, we learned that 1, 2, 3, 4 all should be present. In R2, 4 was not present. So that care I will take. So 1, 2, 3, 4 all should be present. So okay, 1 is related to P, 2 is related to Q, 3 is related to R, and let's say 4 is related to R. Write in the chat box whether or not this is a function. If you think that yes, this is a function, write yes. If you think not a function, write no. Yes, no, yes, no, yes, no. Dhananjay and Makran, what do you think? Dhananjay, what about you?
Sir,
Write in the chat box, Dhananjay. I cannot hear you in the mic. So this is a function. This is a function. Now, Makran, if you might be thinking, so 3 is also related to R and 4 is also related to R, how can this be a function? So keep this in mind. What is the definition here? What condition do we have to impose? That each and every element, each element of A related to 1. So 1 is related to exactly one, only one element, that is P. 2, 3, 4, all the elements are related. Each and every element of A is related to exactly one element of B. Is it said the opposite way, that every element of B should be pre-related to 1 only? If you think about 3 and 4, 3 is related to exactly one element R. 4 is related to exactly one element R. So the condition is satisfied. You need not bother if they are both getting paired up with the same element. So R4 is a function. Okay. You can star mark this example. The generally students get confused here. That so how come it is, they think that it is not a function. Now consider,
Sir?
let's, yes, tell me.
So what about R3 then?
R3, okay. Now in R3, what was happening? The element of A, what do we have? Each and every element of A is related to exactly one. 2 was related to Q, and the element of A only, that is 2, was related to P. Are you getting?
Yes, sir.
It was not related to exactly one element of B. We got an element, it was related to more than one elements of B. That was the problem in R3.
Okay, sir.
Okay. Now R5 is, let's say, 1 comma Q, 2 comma Q, 3 comma Q, 4 comma Q. R6 is equals to 1 comma P, 1 comma Q, 1 comma R, 1 comma S. R5, R6. Tell me which of them is a function, which of them is not a function. It may be that both of them are functions, both of them are not the functions. R5, R6, just type 5 yes, 5 no, 6 yes, 6 no.
So once can you go to the definition, sir?
Please mute your mic.
Sure, sir.
Pujita, your one answer is correct, one answer is wrong. Dhananjay, write in the chat box what's your answer. Yes, Pujita. Now the answer is correct. Okay. Dhananjay, that's correct. What about R6? Correct. Makrand, are you getting? What's your answer, Makrand? R5 is a function. The case of R5 is similar to R4 only. In the R4, what did I give you? We talked about element 3 and element 4. Element 3 and 4 both were related to same element R, but that did not create us any problem because we want that every element of A should be related to exactly one element. I did not tell you they should be different elements. So both are related to R. That's not, it should not give us, it should not be a concern for us. In R5, 1, 2, 3, 4, all the elements of A are related to something. 1, 2, 3, 4, all the elements of A are related to some element. Okay, they are related to, all of them are related to exactly one element. Now, if all the elements are same only, Q, 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 okay, no problem for us. So R5 is also a function. Okay. And what about R6? In R6, one is related to P also, and the same element one is related to Q also. Forget being related to R and S, means that creates more hurdle. But even if I just give you one related to P and one related to Q, that much is sufficient to discard this R6 as a function, not a function. Okay. This is not a function. Important remarks you can write here. If I tell you to write the arrow diagrams for these questions, yeah, at this point, just consider we will draw arrow diagrams for some of these six relations, the sum of these six functions. R1 is 1 related to P, 2 related to Q, 3 to R, 4 to S. So the first R1 arrow diagram is very easy. 1 P, 3 to R, 4 to S. This is for R1. Okay. For R2, it will be what? R2, it will be now R2. Wait, I will just draw the relations of some R R3. I will draw R3. 1 is related to P, 2 is related to Q, 3 to R, 4 to S. 1 is related to P, 2 is related to Q, 3 is related to R, 4 is related to S, and 3 is also related to Q. So this becomes my problematic element. And there I found a single element which has two images. So this was the image. This was the arrow diagram of R3. So R3 here is not a function. R3 is not a function. The point that I want to give you two remarks in the next statement. For those two remarks, I want for that thing, this arrow diagram will be helpful. 1, 2, 3, 4. P, Q, R, S. This is A, this is B, and I'm drawing the arrow diagram for. Now we know that R4 is a function. Okay, we know that R4 is my function, and how the arrow diagrams for R4 looks like. So 1 is related to P, 2 is related to Q, 3 is related to R, and 4 is also related to R. Take note that there remains a single element. There remains an element S in B, which is not related to anything, which is not pre-related to anything. That will be a more correct statement. S is not pre-related to anything. S is not the image of any element. Okay, S is not the image of, so S remains empty. So that tells us it should not create a problem. We should only concern with the first set. First set, all the elements should get paired up and paired up in a single way only. So R4 is a function, and let's say, okay, so that's it. Okay. So now write these remarks. If F is a function from A to B, that is, of this thing, if F is a function from A to B, that is F to B, then there may be an element in set B which is not related to any element in set A. But end of set A should be related to some element of set B. Does this make sense to all of you? From A to B, if you're going in the forward direction, in the first set A, each and every element should get paired up. But in the second element, there may be some unpaired one. There may be some lonely element. Is this making sense? If you are having doubt right now, please unmute immediately. Second remark is, every element of set A has exactly one image in set B, but an element in set B may have, okay, may have zero, one, or more than one pre-image in set A. In the first example also, there underline this way. There may be. F is a function. If I just illustrate these examples by arrow diagrams, so let's say in the mapping f is a function from set A to set B. So let's say PQ S P U V. There are three elements PUV, which does the first remark. There may be an element is B, which is any element in A. There are three elements, okay? But every element of A should be related to something. The first example related to the first remark, and the example related to second remark also. Now let's say now every element of set A has exactly one image. Now you count the images of one. Let's say one, the set element one. How many images does it have? The only image is P, so it has only one image. The element, sorry, the element two. Two, how many images does it have? Only P is there, so exactly one image. Three, how many images? Only P. Four, how many images? Only S. So every element of A has exactly one image, but an element in B, it may have zero images. Let's say pre-image. So let's say consider R, T, U. If you consider the element R, element T, element U, they do not have any pre-images. So that is zero pre-images. An element may have one pre-image. So let's say S. S has one pre-image. That is 4. Or an element may have more than one pre-image. For example, element P. Element P has 3 pre-images. 1, 2, 3. Do you get the second remark? Okay. So remember these properties. Now moving ahead. Some notations. What is the meaning of some notations? Let's say let f from A to B be a function. Okay, so f from A to B, that is the mapping from A to B, is a function. This is given to you. Then domain of f. What is the meaning of domain of f? In the relation part, what did we saw? We saw that there's a domain of a relation. Means see, the function, when we are talking about function, is a relation only. Yes or no? So domain of a relation, we know that, sir, in the ordered pairs that we get, collect all the first elements. So the set of all the first elements which actually form their pairing, which actually get paired up with something, which actually form some images, they are together called as the domain. So here in the function, we see that in the definition only the condition is there that all the elements of set A should be there, should be formed as an image. So can I say that domain of f is equals to, you can give the definition also as set of first elements in the ordered pair, elements in A cross B. Sorry, 1 minute, this is all wrong, I have written. So just write domain of f is equals to set A. Let's say set of elements of A that form an image under the function f. And because f is a function, so you can directly say that all the elements of set A will form an image. So domain of f is the first set A only. What is the meaning of codomain of f? Codomain of a relation, you know that. So the second set was directly called as the codomain. Yes or no? So here also the set B is called as codomain, and here nothing changes in terms of codomain. All the elements of the codomain will have a pre-image. It is not necessary. Some elements of B may have pre-image, some may not have. So codomain, nothing significant. What remains is range of f. Range of f. So what is range of f? The same definition, set of elements of B that have some pre-image in set A under the function f. In the function f, those elements should have some pre-image. Okay. So range of f, you can also write it as range of f is equals to set of all y belong to B such that x comma y belongs to F for some x. At least there should be one x belonging to it, such satisfying this condition. X, y belongs to F. Okay. We will also see some more notations. Now, definition part is this much only. I just have to acquaint you with the notation part, how to write these things in a notation using the notations and symbols. So just consider one example. Let's say consider set A is equals to x belonging to natural numbers and x less than 5, and consider this relation f of x is equals to x plus 1. This f of x equal to x plus 1, this I have just given you a mapping. So determine whether f from A to, let's say, n is a function. Okay. This is a first question. This is the A part. Second part, what is f of 2 domain of f range of f codomain of f. So I will solve this question for you. This one is a very easy question. So f of x equals to x plus 1. So can you see that the two sets that we have, first set is A. A is equals to, in the listing form, if you write, you can easily see that A is equals to 1, 2, 3, 4. And B, the set, another set is n of natural numbers. So now we have that mapping. Now each and every element of the first set is A, it should be related to some element, exactly one element in the another set, second set, that is n natural numbers. So can you see that the first element f of 1 is equals to 1 plus 1 is equals to 2. So 1 is related to the element 2. 2 is related to the element 3 of natural numbers. 3 is related to the element 4 of natural numbers, and 4 is related to element 5 of natural numbers. All these elements should belong to the second set, that is my natural numbers, and this is true. Yes, it does belong, so we do not have any problem. So we can say that yes, so the condition of function is satisfied. Each and all the elements of set A are related to exactly one elements. So yes, the condition of function is satisfied. It is a function f of 2. F of 2, what will be f of 2? So f of 2 will be equal to 2 is related to the element 3. Domain of f is the first set only. Domain of f is the set A. Range of f is the set of images. A codomain, if I tell you what is the codomain of f, codomain is the second set. Second set is natural numbers. But are all the elements in the natural numbers related, have some pre-images? What is our definition of range? Range of a function is same as range of a relation. Relation range, what did we have? Set of second elements. So a set of second elements which actually form a pre-image. So only few elements are there. Which are those? 2, 3, 4, 5. So this is my answer for range of f. Is this example clear to everyone?
Yes, sir.
Whether f is a function of or not. If yes, find domain of f, codomain of f, and range of f. First, give me the answer of the first question, whether f is a function of or not. After that, go for the further part. In the chat box, think for a while, and then in the chat box, write yes or no. If you think f is a function, write yes. If you think it's not a function, write no. Pujita, your answer is wrong. Only two answers are there, 50-50% probability, either yes or no. Yes. Others also, those who joined late, are you understanding what is going on? Sanat, Afrin, Keshe. Sanat, answer is wrong. Okay, see students now here. If we consider in the plain format f from z to n, and the mapping f of x is given by x square. For this set A, that is first set to set B, if you observe what is Z, Z is my set of integers, which is given by dot 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 -3 -2 -1 0 1 2 3 dot 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 up to infinity, and natural numbers we all know 1 2 3 5 6 7 8 up to so on. F of x equal to x square. What is the target? We have to see that each and every element of the first set Z, its square when we take, it should belong to natural numbers. So if you take f of 1, if you take f of 1 is equals to, sir, 1 square, that is 1 only. Yes, sir, it belongs to natural numbers. F of 2, it is equals to 4, it belongs to natural numbers. F of 3 is equals to 9, it belongs to natural numbers. This can go on. Similarly, for negative integers also, no problem. F of -1 also you will do. It will be 1 only, so it belongs to natural numbers. F of -2 also, it is equals to +4, belongs to natural numbers. F of -3 equal to 9, belong to natural numbers. But there is an element f of 0 whose mapping is 0 square, that is 0, which does not belong to natural numbers. So this element 0 of the integers, this creates a problem. I have found an element in my original set, in my first set, which does not, it's mapping, the image under the mapping is not present in the second set. Hence, our condition is violated. Okay. Two conditions are there. Every element should form an image. So all should form an image and they should form exactly one image. So the elements, those which were actually forming an image, yes, they were forming exactly one image. So that condition was satisfied, that exactly one image was being formed. But 0 was, I found one element which did not form any image. So the condition is violated. So this is not a function. In plain and simple terms, you can write this is not a function. Okay. For the starting point, if I just tell you whether this mapping f from z to n is a function or not. If I tell you now, see in the exams how the questions are asked. If I ask you this question, my language is this. What is my question language? If my language is this, whether f from z to n, f of x equal to x square is function or not. So what is the answer of this question? The answer of this question is definitely no. Definitely no. So 100% this is not a function. No, it is not a function. But if my language is this, now see, first when I tell you f from z to n, f of x equal to x square, whether this is a function or not, and you determine, no, so this is not a function. So the further argument about domain, codomain, and range is meaningless. If it is not a function, how can we question, how can we answer about domain, codomain, and range? All those things become meaningless. But if I tell you find the domain of f of x equal to x square, where f is a mapping from the set z to set n. So now what I'm telling you, I have predetermined, the question paper setter has predetermined this is a function. Actually, in the true sense, this is not a function. F of x equal to x square from z to n, this is not a function. But what he has told you, his language was find the domain of this mapping. So means what? Actually, the language, what he wants to convey you is this, the message that is conveyed from this thing is, for f of x equal to x square, for this mapping to be a function, in order that this mapping should be a function, what should be my domain? So your domain should be, either you can construct your domain in two ways. What is the first way? Sir, those points, those elements of in the first set, in my this first set which is there, those elements which are there which does not form any images, which do not form any images, you include their images in my second set. So that way you can alter the second set and you can make the adjustments for this mapping to be a function. Or what is the another process? So here in the example that we saw, 0 was a problematic element. Some elements are problematic. In the first set, f is f from z to n. In this first set z, some elements are problematic. Some elements problematic means what? Either they may form more than one images. We want exactly one image, no? So they may form more than one image, or they may not form any image at all. So these are called as problematic elements. Now, problematic elements is a loose term. It's not a standard word. It's just a made up word made by me in order to make you understand. So these problematic elements, we can remove those. If I just remove those elements from this first set Z, then I can tell that this mapping is a function. So what I will do, I know that all the elements of this set Z, 1, 2, 3, 4, 5, 6, 7, 8, minus 1, minus 2, minus 3, minus 4, they were forming exactly one images. Only 0 was the problematic element. So what I will answer this question, if you want to find the domain of this set. So the domain, I will write it as, so domain is equals to, domain will be equal to complete set Z except that element 0, Z minus that singleton 0. Subtraction of sets operation that you remember now, A minus B operation. Set Z minus singleton set 0. This will be my domain. This will be my answer. So the meaning of the question is that actually it's a long form. The full form of the question is, in order to make the mapping to be a function, what should be my domain? So itna lamba kaun likhenga, why to write such a big statement? So it just writes find the domain of f of x. Okay. So fourth, in the future, in the whole chapter of a functions and relations chapter, whenever I will tell you to write find the domain of this function, you just have to write. I will explicitly mention first for the practice part. First, we will explicitly see whether some mapping is a function or not. After that, I will give you the questions about whether find the domain of the questions. And when I write find the domain, just you have to understand find the domain means what? Sir has understood that f is a function. Sir has to make f to be a function. Make some suitable adjustments in the first bit. Okay. Now moving ahead. The mapping is given by f of x equal to 1 upon x. Function or not. Answer question number 3. Yes, no question it is. Few examples I will just give you yes, no questions. Which is the wrong. R is set of real numbers. Okay. Makrant correct. Dhananjay correct. Others, Sanat, Keshav, Afrin. Are you understanding? So this is a function. This is a function because if you take any natural number, let's say 5, 1 upon 5 will be the image, and 1 upon 5 is present in real numbers. All the natural numbers, they form exactly one image, 1 upon x. It's a unique image, exactly one image, and that image is present in this real numbers. If I tell you, let's say, let me write z, f of x equal to 1 upon x. Same. Mapping is same. I just change the first and second set. Function or not? Just yes, no questions. Fifteen seconds questions these are. Dhananjay. Makarand, your answer is wrong. Think again. Pujita, right. This is not a function. Why this is not a function? Because set is from function f from z to r. Z, what is the element? There is, if I just tell you function or not, so in the set z there is an element. Which element? 0. There is an element in set z which does not have any image. What will be the image of 0 under this mapping? So 0 will be mapped to 1 upon 0. Is 1 upon 0 defined? No, it is not defined. So the reason is 0 belongs to set z, and f of 0 does not belongs to my the set B, that is set R. Okay, so 0 is a problematic element. So if I just give you the language, whether function or not, you should say no, sir, not a function. My first set is set of all real numbers except 0 from there to R. No, 1 minute, from there to N. F of x is equals to 1 upon x. Same question, function or not. Now 0 was the problematic element. I removed that element. Okay. From the set of real numbers, I removed 0. So all real numbers except 0 is my first set. Same mapping, f of x is related to 1 by x. Whether this is a function or not. Whether this mapping. The answer is no. This is not a function. See, now what is the reason of this statement? Why it is not a function? In the first set, in my first set A to B, in my set A, there are lot many real numbers whose image is not a natural number. I have to, what is my condition? Each and every element in set A should form an image. Consider Consider x is equals to, let's say, whatever number you like, you take it. Let's say 2.5. Now this 2.5 belongs to my first set A. Is this correct? R minus is singleton set 0. 2.5 belongs to that. 2.5 belonging to R minus 0. What is f of x? F of x is equals to 1 upon 2.5. Little simplification, it will give me 2 upon 5. Correct? Now, whether this f of x, whether this image belongs to the set of natural numbers? No, it does not belongs to the second set natural numbers. So we have that f of 2.5. There is an element in real, the first set, whose image does not belongs to the second set. Yes or no? So even if there is one single such element, we will discard it as a function. Like such, we can find infinitely many such elements, which will be problematic. Okay. So the same mapping, all these questions, why did I give you together? Just observe that mapping is same. F of x equal to 1 upon x, 1 upon x, 1 upon x. Just by changing this set A and set B, set A and set B, set A and set B, I can make that mapping to be, sometimes I can make it to be a function, sometimes I can make it to be a not a function. Okay, now answer this. What is given? This f is a mapping from R to R, means set of real numbers to set numbers, and f of x is given to be equal to 1 upon x. Find the domain of f of x. This is the question. Domain of this f of x, r minus 1 upon 0, no. Pujita, r minus not singleton 1 upon 0. 1 upon 0 is not defined only. Domain you have to concentrate on the first set. Domain, you have to concentrate on the first set. So in the first set, from the first set, just remove the problematic points. To now the question paper, he has asked you that this is a function. In the question statement only, he has given you find the domain of this mapping. So he is bound that, so this is a function. In order to make it a function, what should be the domain? So in order to make it a function, what should be the domain? From the first set, that is real numbers, just remove the problematic points. So the problematic point is only 0. For 0 only, 1 upon 0 is not defined. So 0 is my problematic element, not 1 upon 0. So I will just write domain is equals to set of real numbers minus problematic points. So set of real numbers minus problematic point is 0. This problematic point, this is a loose word. Okay, this is not a standard mathematical word. I have just made that up to make you understand. So this will be my domain. Okay. All right, make this correction. From N to Z it is, okay. Make it here W, set of whole numbers. F from W to Z, X belongs to W, Z, Y belongs to Z, whether F is a function or not. Okay. Dhananjay's answer is correct. Pujita, your answer is wrong. Dhananjay, correct. Pujita, check again. Okay. Makrand, your also answer is wrong. Okay. Dhananjay, you can unmute yourself. Explain the reason.
Yes, sir. So, whole numbers start from 0 and until infinity, sir. While integers, there's negative numbers are also there, sir. So, when y belongs to integers, we can't have negative numbers, so it could not be a function, sir.
When Y belongs to integers,
Yes, negative numbers cannot be included because whole numbers do not have negative numbers, sir. So,
whole numbers do not have negative numbers. That is correct. But X is from the whole numbers and Y is from integer, from the negative. Y can be negative also. No, that will not create a problem.
yes, sir.
You are telling it is not a function, but the reason that you're giving is not correct. You're not able to explain the reason. What is a condition? See, I've given you the answer. The answer for this question is this is not a function. Okay. So now what is a condition for a mapping to be a function, not function or not? Every element of the first set, means of the first set W, it should have exactly one image. Every element should have an image and every element should have exactly one image. So which of these conditions is getting violated? If you are telling that this is not a function, some condition should get violated, no? Which is the condition that? So just see here the explanation. If I just see F, how this mapping will look like. F mapping is the first set. You have to consider the ordered pair. In this ordered pair, first element belongs to the first set W and my second element belongs to the second set Z. Okay. And he has given the relation between the first element and the second element. So the first element is square of the second element. Okay. So let's say if my first element is 0, what will be my second element? My second element will be 0. Okay, fine. If my first element is 1, what will be my second element? My second element can be 1 also, and my second element can be -1 also. Is this making sense? The second element belongs to the integers. So the second element belongs to the set of integers. So 1 also and -1 also, both will be there. After that, in my first element, the first element, if I take 2, what is f is equal to f of equal to x comma x equal to y square. So 2 is related to what? 2 is not related to anything. So this element, this ordered pair, actually this ordered pair will not be included in my f, because 2 comma something will not be included in f, because 2 is not square of any integer. If I cannot take x equal to 2, do you see this? I cannot take x equal to 2 because it will not be equal to any integer square. So 2 will not be present here, 3 will not be present here, 4 will be present. Yes, correct. 4 will be present. So 4 will be is 2 square also, and 4 is -2 square also. There y can take 2 or can take value of 2 as well as can take the value of -2. So here both the conditions of functions are getting violated. If I draw the arrow diagram for this thing, if I give you the explanation using arrow diagram, so this is 0, 1, 2, 3, 4, 5, and lots of many other example. Let's say 0, 1, -1, 2, -2, 3, -3, dot, and so on. 1 is related to 1 also, and 1 is related to 2 also. So can you see that this 1 is my problematic point? I want that element should be related to exactly one element. Here that element in set A, that is the first set, is related to more than 2 elements, more than one element. Similarly, 4 is related to 2 also, 4 is related to -2 also. So 4 is also a problematic point. It is related to more than one elements. Other than this, means this is one problem. Other than this, more problem is there. What is another problem? If you consider this 0.2, 0.3, 0.5, they are sitting idle. They do not form images with any of the elements. So both the conditions of the definition is being violated. That is, the set should form an image. Each and every element should form an image. So that each and every element, that condition is getting violated, and each element should form exactly one element, exactly one image. That exactly one image, that condition is also being violated. So this mapping is not a function. Okay, so not a function. One belongs to W, and one forms two images. 2 belongs to W, and 2 has no image. Okay. So this is the reason for the answer. same mapping I have given, just same W's that I have given you, just mapping I have changed a little bit. Here it was x equal to y square. Here I have given you x square equal to y. Whether f is function or not. Makrand and Pujita, correct? What about Dhananjay? Afrin, are you understanding what is going on? You do not respond in the class. That's all.
Yes, sir.
Okay.
Sir, are you able to hear me?
Yes, yes, Afrin, I can hear you.
Okay, sir. Sir, actually, I'm a bit busy, sir, because in my school there our student council investiture ceremony is going on. So that's a bit busy. We are a bit busy scheduled, sir. So I am not able to concentrate. In between, my teacher is sending message that see to that and give me information soon. So in between, I am just speaking to my teacher also, sir. So
Okay. Okay,
I am
fine.
not responding you in between.
Okay. Okay, so this mapping is a function because here if I just tell you, just draw the arrow diagram. If I just give you the first set is set of whole numbers, the second set is of integers. It will start from 0, 1, 2, 3, 4, and so on. And x square is the second element. X is means if I choose any element, let's say 0, what will be the image of this x? If x is equals to 0, the image of this x is its square, and square of any number is unique only. Means if I take 0 square, it will be 0 only. It does not lead us to two places. When I will take square, it will land me at one place only. One, when I will take it square, it will land me at one place only, that is 1. It won't me take it to two places. 1 square. If I take 2, if I take x equal to 2, the image of x equal to 2 is y, that is y equal to x square. So 2 square, it is a single number, it's a unique image, so that is 4. So what about this? Okay, if I take 3, x equal to 3, so it will have a unique image. 3 square is a single number, that is 9. So what about these elements? Means 1 is there, 4 is there, 9 is occupied, but some numbers are not occupied, that is 2 is left, 3 is left, then 5, 6, 7, 8, and so on. These elements are left empty. What about them? So if elements are left empty in the second set, that should not cause us any problem. This we saw earlier also. Only the elements in first set, each one should be occupied with something, and which exactly one of them. In set second, if some elements are being empty, not a problem, not a concern. So this is a function. This mapping is a function. Okay. So in the next class tomorrow, we will see graphs of the function, how to draw the graphs of a function. And after that, we will jump to domains and range. After that, after graphs, we will see some standard functions that is given in the NCERT. And then the main part of this chapter will start. Domain and range, how to find the domains. Lots of interesting questions get found over domain. So two, and after that it will be a very high level stuff. So thank you. That's all for today.
Sir,
Yes, tell me.
sir, I'm unable to access the videos of last week of 30th and 31st. And I missed those classes. I was
Okay. So those videos were the links shared to you.
Yes, they were, but when I open the link, it says error. So there's no video.
Is that problem getting caused for everyone or only to you?
For me,
Dhananjay?
I have.
Sir, it's the same for me also, sir.
Dhananjay, you also same problem?
Yes, sir.
Yeah, I don't know, the problem should not be there. Okay, let's see for today. Means maybe those for one day it may have happened directly because just once again.
No, sir.